So we're doing OCRs, paper 5, the non-calculator paper from June 2018. And if we have a look at the grade boundaries, we need 17 marks for a 4, 28 marks for a 5, 39 marks for a 6, and so on. So question 1, we've got two fractions to add, and we're looking for an answer as a mixed number in simplest form. So first things first, we need common denominators when adding fractions. And if we just multiply these together, 5 times 8 is 40. So we get 40ths in both cases. I multiplied 5 by 8 to get 40. So I'm going to multiply the 3 by 8 to get 24. I multiplied the 8 by 5 to get 40. So I'm going to multiply the 5 by 5 to get 25. And these are what we're going to add together. 24 40ths plus 25 40ths is still 40ths, and we just add the numerators, we get 49 40ths. We need to convert this to a mixed number. Well, 40 of these 49 40ths will be a whole 1, and then there's 9 40ths left over. So we've got a whole 1 and 9 40ths. Looking to simplify this if I can. Don't forget this might simplify sometimes as well. I can't half the top, half the bottom because I'll get a decimal, and I know that 40 won't divide by 3, even though 9 will. I think this is final answer. Mixed number in simplest form. Part B, we've got a subtraction to do where numbers are given in standard form. What we can do is make these standard form numbers the same. So this first one is 5 times 10 to the 4. I'm going to do one of these times 10s and get 50 times 10 to the 3. There's only 3 times 10s left if I do one. I'm then going to subtract 1.6 times 10 to the 3. When I've got matching powers of 10, I can just do 50, take away 1.6. So 50 take away 1.6 will be 48.4, and because I've got times 10 to the 3 and times 10 to the 3, my answer is times 10 to the 3. This is the correct answer to the calculation, but it's not in standard form. This number here is above 10, so I need to bring this number down by a power of 10. So I'm going to divide this by 10 and get 4.84. To compensate for that, I need an extra times 10 in my final standard form conversion. 4.84 times 10 to the 4 is the same as 48.4 times 10 to the 3. So in question 2, we've got an inequality and someone solved it and put the solution on a number line, and it's wrong. So we're going to solve this inequality and see what happens. So we've got 3x plus 1 is greater than negative 5. Just treat this like an equation, same thing to both sides. So we'll take 1, and we get 3x is greater than negative 6. And then we're going to divide by 3 and divide by 3. And we get x is greater than negative 6 divided by 3 is negative 2. So this is the solution to the inequality that we need to place on the number line. Well, negative 2 is important, so there will be a circle at negative 2. And we've got x is greater than negative 2. So rather than coming lower, we want to go higher. Question 3, we've got some vectors to add together. Well, that's as simple as just adding the tops and adding the bottoms. So we're going to do negative 3, add 5, start at negative 3 and go up by 5. You will finish at 2. And 2 add 7 is 9. Part B, we've got a similar thing, but we've got a multiplication of a vector here. So we'll deal with that first. We've got to do 2 lots of 1 minus 3. Well, 2 times 1 is 2. And 2 times minus 3 is minus 6. So what we're going to do is start with the 3, 4. And rather than take away 2 lots of 1 minus 3, I'm going to take away this. which is 2 minus 6. And then just going to follow the same thing we did above. So 3 take 2 is 1. And 4 take negative 6 becomes 4 add 6, which is 10. Question 4, we've got some nutritional information about 110 grams of cereal. This is the information. And we've got someone saying more than 90% is carbohydrates. So we want to really know what 90% of 110 is. That's what we're looking for. So 90% of 110. And we'll see if it matches this figure here. Well, 10% is going to be 110 divided by 10, which is 11. And then if I want 90%, I'm going to times 9. Times 9, you'd get 90%. And 11 times 9 is 99. So 90% is 99 grams. Up here we're saying 99.4 grams is carbohydrates. And that is more than the 90% we just found. Okay, 99.4 grams is more than 99 grams. Is Emily correct? Yes. Why? Because 99.4 grams is bigger than 99 grams, the 90% that we just found. Question 5, we've got a table showing relative frequencies of results from a football team after a number of games, and it says complete the table. Well, when you've got relative frequencies, these boxes, these probabilities, which is what relative frequency is, needs to add up to the whole one. So 0.2 added to 0.45 is 0.65. And 1 take away 0.65 is this missing box here. And 1 take away 0.65 is 0.35. Part B says the team lost 10 more games than they won. So I'm looking at the difference between lost and won. So if we just look at these relative frequencies and say, okay, if I look at the difference between those, 0.45 take away 0.2 is 5 take 0 is 5. That would be 2. 0.25. That 0.25 represents 10 games because that's the difference between how many they lost and how many they won in terms of relative frequencies. What we can do is use that to figure out how many games they played altogether. Well, if 0.25 represents 10 games, then I can multiply that by 4 and multiply that by 4. 0.25 times 4, a quarter times 4 is 1. That 1 is everything when it comes to probability or relative frequencies. So multiply this by 4. They played 40 games altogether. Question 6, we've got some information about text messages, and it says Jack sent 15% more messages in March than in February, and in March he sent 460 text messages. So what we've got to think of is two separate things here. We've got February is 100%. And that's what we're trying to find out. What was the text message he sent in February? In March, he sent 15% more text messages, and that took him up to 460. Now, if he sent 15% more messages, he sent 115%. So what we've got to try and do is scale this diagram from 115% down to 100%. It's not an easy one to do. But I think what we can do is come down maybe to 5%. So I need to know how many 5s go into 115. 5s into 1 is 0. 5s into 11 is 2, remainder 1. And 5s into 15 is 3. So to get from 115% to 5%, I'm dividing by 23. That's why this is a difficult version of this question, because it's not an obvious scale down to scale back up. But anyway, we're going to now divide this by 23. So we're going to say how many 23s in 460. 23s into 4 is 0, remainder 4. 23s into 46 is 2. And 23s into 0 is 0. So 5% is 20 text messages. What we can do is now scale this back up to 100%. How to get from 5 to 100? There are 20 5s in 100. 5 times 20 is 100. So what we need to do is multiply this by 20. And 20 times 20, 2 2s are 4. And then we've got 2 zeros to bolt on the end. He sent 400 texts in February. You can double check this and see what would 15% of this be. Well, 10% is 40, 5% is 20, 40 add 20 is 60, and 400 add 60 takes me back to the 460 that we were given in the initial question. Question 7, loads of information in this question. But what we've got is a floor being tiled with carpet tiles. And straight away it says each tile is a square measuring 50 centimetres by 50 centimetres. And in my plan of the floor, I'm in metres. So the first thing I'm going to do is convert these to centimetres. If we times that by 100, 4.5 times 100 is 450. And that's now centimetres. I'll do the same here. 3 meters multiplied by 100 is 300 centimeters. So a quick conversion just to make sure I've got matching units. What we're going to do now is see how many tiles across and down I'm going to need to fill this floor. Well, each tile is a square 50 by 50. So let's see how many tiles going across the room. I'm going to do 450 centimeters divided by 50 because each tile is 50 centimeters. So I can simplify this. That's the same as 45 divided by 5, which is 9 tiles across. We can do the same thing and see how many tiles go downwards. So I'm going to do the same calculation, but this time we've got a length of 300. And we're going to divide that by 50 because each tile is 50 centimeters. Again, quick simplification. 30 divided by 5 is 6 down. Work out how many tiles he needs altogether. Well, if he needs 6 down and 9 across, then the total is 6 multiplied by 9, which is 54 tiles. Back to the question, it says the tiles are sold in packs of 10 and each pack costs £20. So we're only sold in packs of 10 and each pack is £20. So this is no good. I'm going to have to buy 60 tiles, which is 6 packs. And if they're £20 each, 6 times 20 would be £120. So that's what we're spending on tiles. Final part of this question says Tim pays for fitting at a rate of £7.50 per square metre with any fraction of a square metre rounded up. So we need to know how many square metres altogether in this floor plan. Well, we'll go back to my metres that I had. We had 4.5 metres and we had 3 metres. So we'll use meters again because we're looking for square meters here, and we need to do 3 multiplied by 4.5. 3 times 4 is 12, so this is saying 3 4s are 12 and 3 lots of a half. So 3 4s are 12, 3 lots of a half is a half of 3, which is 1.5. There are 13.5 square meters of floor. It says with any fraction of a square meter rounded up. So we're going to pay for 14 square meters. We need now to figure out what that's going to cost us. So we need to do 14 times £7.50. So 14 times £7.50. We're going to do 7 times 14. I'm going to break this apart. I'm going to do 7 times 10, which is 70. I'm going to do 7 times 4, which is 28. And then I'm going to do 0.5 or a half, lots of 14, which is 7. If I add those together, I've done 14 times £7.50. It's like doing 7 times 14, which is 7 times 10 added to 7 times 4. And then I'll also add on a half of 14. 70 add 28 is 98. Add 7 is 105. This is the cost of the fitting. Down here, we've got the cost of the tiles. Total cost is going to be 105 added onto 120, which equals 225. Question 8, we've got someone wanting to display all the possible outcomes when rolling 2 fair 6-sided dice. Why is a tree diagram not the best method? Well, a tree diagram looks like this. You'd have branches and then branches. And if we're rolling a dice, this first set of branches, you'd have to have 6 possibilities. 1, 2, 3, 4, 5, 6. So the reason that that's not a good idea is you'd have too many branches. There'd be 6 branches and then another 6 branches coming off of each branch. Far too many. Part B, draw a sample space diagram to list all the possible outcomes. Well, a sample space looks like this. We've got the first dice. We've got the second dice. And what we're doing is adding these together. So we just need to work out all the possible answers. 1 add 1 is 2. 2 add 1 is 3. And you can see you get quite a nice pattern with this. 1 add 2 is 3. And there's your completed sample space diagram. Part 2, show the probability of the score on the 2-sided dice adding to 11 is 1 out of 18. So we're looking for all the 11s. Well, there's an 11. There's an 11. There are 2 11s out of altogether 36 outcomes. So the probability of an 11 is 2/36, and that simplifies to 1/18. Question 9, we've got a function that says y is x cubed, take away 3 lots of x. We've got a bunch of x values, we've got a bunch of y values, and we've got one y value to figure out. So we're going to take this -1, which is an x value, and we're going to cube it. So we need to do -1 cubed, and then take away 3 lots of -1. Take away 3x. Well, -1 cubed is -1 times -1. That's 1. Times -1 again is back down to -1. I'm going to take away 3 times -1, which is -3. We're taking away -3. This becomes -1, add 3, which is 2. Part B, we've got to draw the graph of this function, and we're going to use this table as a set of coordinates. So we've got to go across to -3 and down to -18. Be careful with the scales on this one. Going up and down, it's not going up in ones. 1, 2, 3, 4, 5. Each little box is only half. If we look, 2 boxes, 1, 2, 3, 4, 5 represents a whole number. So just be careful with that. Cross to -3, down to -18. Cross to -3, that's -20. -19, -18 would be there. Across to -2, down to -2. across to -2, 1, 2. I'm counting 2 boxes for each number. Across to -1 and up to 2, across to -1, 1, 2. No is easy. Across to 1 and up down to -2, across to 1, 1, 2. Across to 2 and up to 2, 1, 2. And across to 3 and up to 18, across to 3 and up to 18 would be there. And what we need to do is try and connect these with a smooth curve. It's going to be a bit rough on the device I'm working on, but I'll try my best. That's not too bad. Final part says use your graph to solve x cubed minus 3x equals 10. Well, if we look back up here, this was x cubed minus 3x equals y. And now we've got x cubed minus 3x equals 10. The y has changed to a 10. So that's what we need to find. Where is y equal to 10? Well, here's y. Here's 10. This line here is y equals 10. And all we're looking for is the x value of that where we cross this graph. So I'm going to literally look where they cross, read down, and that's 2.5, 2.6, something close to that would be full marks. And we're looking at a car's dashboard and it's talking about how much fuel is left in the car. We also know how many miles have been travelled. So we started with a full tank and we're now down to this. So I'm going to write a fraction. This looks a bit like a fraction bar. A fraction for how much fuel has been used. So there's 1, 2, 3, 4, 5, 6, 7, 8 parts in this bar. And we've used 1, 2, 3 of them. So we know that 3/8, that's how much fuel has gone. And that must be worth 165 miles. If we've used 3/8 of the fuel and we've gone 165 miles, then I can write that equation there. If I can work out 1/8, then I can work out a full tank. So I'm going to do that now. Well, if 3/8 is 165 miles, then 1/8 must be 165 divided by 3. So I'm going to work that out now. How many 3's go into 165? 3's into 1 is 0. 3's into 16. Well, 3 6's are 18. 3 5's are 15. So it would be 5 remainder 1. And 3's into 15 is 3. So what this is saying is 1/8 of the tank is now 53 miles. If I know what 1/8 of the tank is, I can work out 8/8, which is a full tank. How do we do that? Well, I know that 1/8 is 53 miles. I want 8/8, so I'm going to do 53 multiplied by 8. 8 3's are 24. 8 5's are 40. Add on this 2 would be 42. The car will do 424 miles on a full tank. Part B says, what assumptions have you made when answering part A? And the big assumption here is that the car uses the same petrol all the time. So if this car is full of petrol, it'll use the same amount as it's travelling as it would when it's empty, and that's just not true. Same, if this car was going fast, it would use a lot more petrol than if it was going slow. Question 11, we've got 2 triangles connected, and what we're looking for is the length of AB, which is this length. If you've ever got 2 triangles connected, chances are you'll need to find the line connecting them first. This usually comes last. So I'm going to work on this right angled triangle first and see if there's anything I can find. Let's try and find this side. We know that that's 60 and we know that that's 12. This to me looks like a trigonometry question. So we've got the opposite, the side across from the angle. We know the longest side would be a hypotenuse, and that leaves this to be an adjacent. This is a hypotenuse adjacent question, so I'll quickly write toa and figure out which I'm going to use. Adjacent hypotenuse. This is a cosine question, so let's write that down. Cos theta equals adjacent over hypotenuse. Substitute what we've got. Theta is the angle, so we've got cos 60 equals question mark over 12. We need to rearrange this, so multiply both sides by 12 and you'll get question mark equals 12 times cos 60. I know that cos 60 is a half, and that's something you're going to have to memorize or work out. So cos 60 is a half, so this becomes 12 times a half, or a half of 12, which is 6. This is not as final answer because we're actually looking for AB. So I'm now going to work on this right angle triangle. And we know that this is 10 from the question. We just worked out this, which is 6. And we're looking for that top side. Because we're just involving sides, this is a Pythagoras question. So let's label this A, B, and C. And then let's just follow Pythagoras' theorem. A squared plus B squared equals C squared. The thing we're looking for, question mark squared plus 6 squared equals 10 squared. Question mark squared plus 6 sixes are 36. 10 tens are 100. That should have been a plus, sorry. And if something squared plus 36 is 100, then something squared is 100. Take 36, which is 64. Something squared is 64. My question mark, the square root of 64, which is 8. Question 12, we've got someone looking at 64 raised to the power of negative 1/2, and that's their answer. And we just need to find the error and find the right answer. Well, if we do 64 to the half, that is not halving 64, which is what Carol seems to have done. 64 to the half is the square root of 64, and 8 eighths are 64, so that is 8. And then we're going to raise that to negative 1. So 8 to the power of negative 1 is 1 over 8. The negative index just puts 1 over your number, or the reciprocal. So that is the correct answer. What was Carol's error? Well, she halved instead of square rooting. Question 13. We're looking to convert 5 twelfths to a recurring decimal. So we're literally being asked to do 5 divided by 12. So I'm going to see how many 12s go into 5. The answer is 0. So I'm going to need decimal point and some digits to work with. 12s into 5 is actually 0, remainder 5. And now we're looking at 12s into 50. Well, 4 12s are 48, so that would be 4 remainder 2. 12s into 20, and I think that's just 1, remainder 8. 12s into 80, well, 6 12s are 72. So I think that is 6, remainder 8. And then we've got 12s into 80 again. So I'm going to have 6, remainder 8. There's as recurring decimal, 0.5. 4166 recurring. Part B says convert 0.76, where the 7 and the 6 are recurring, to a fraction. So we need to follow as algebraic method for that. We're going to start with x equals 0.7676. Both the 7 and the 6 recur. We need to work through this process and find 10x. All the digits move one place to the left. 7.6767. Do the same again. Multiply by 10. We'll get 100x, and again all the digits move to the left, and you get 76.7676. What I'm looking for through this process is this: the digits after the decimal points match up perfectly in these two numbers, and that's what I want. So I'm going to go back to this and this and write myself a little subtraction. 100x take away 1x is the same as 76.76. And I could write 76 again, but I'll not bother. Take away 0.76. And because of that perfectly matching decimal, these all vanish. 6 take 6 is 0. 7 take 7 is 0. And I'm left with 76 take 0, which is 76. We can answer this part of the calculation. 100x take away x is 99x. And if 99x equals 76, then x equals 76 over 99. And x was our original decimal. So I've turned the decimal into a fraction. It doesn't say simplify, so there's no marks for simplifying. I'll just leave it like that. Okay, question 14. I'm not going to lie, this one's a bit of a monster. What we're looking at is a cylinder and a cone. We've got something down here that says the volume of the cone is equal to the volume of the cylinder. So before I do anything, this is all algebraic, this cone, so I'm just going to work on the cylinder to start with. So let's work out the volume of the cylinder. Well, volume of a cylinder, we need to work out this area. So the area of a circle is pi r squared. And then we're going to multiply by the height of the cylinder. So I'm just going to multiply by 9 there. So what we get is pi times the radius is 2. 2 squared multiplied by 9. And 2 squared is 4. 2 2s are 4. 4 times 9 is 36. And 36 times pi is 36 pi. So that is the volume of this cylinder. We know the volume of the cylinder is equal to the volume of the cone, and we're given a formula for the volume of the cone. So we know that this here must come to 36 pi. So if I write that down, we'll look at the cone now. I'm going to write 1/3 pi r squared h equals 36 pi, the volume of the cylinder. We're given a little bit more information up here, and it says the ratio r to h is 1:4. And they've just thrown in a little curveball here. What we're saying here is we can get rid of either the r or the h. Well, same as I'm trying to find r, I'm going to get rid of the h. And this is saying that h is 4 lots of r. If r is 1 part and h is 4 parts, then h is worth 4 r's. And we're going to use that down here. I'm going to replace that h with 4 r's. So what we get is 1/3 pi r squared. This h is now 4r, so I'm going to times that by 4r. And that's still equal to 36 pi. We can start to simplify this a little bit. So there's pi on both sides. If you were to divide both sides by pi, that would vanish. 4r times r squared is 4r cubed. So we're going to do 4r cubed, that's that bit, multiplied by a third equals 36. We want to make r the subject if we can. So I'm just going to rewrite this and do the 4 times a third, which is 4 thirds, r cubed equals 36. Now this is not too bad an equation to solve. I'm going to times both sides by 3 to get rid of this, and we get 4r cubed equals 3 times 36, well 3 30s are 90, and 3 6s are 18. That would be 108. If I divide both sides by 4, that'll give me r cubed, and 108 divided by 4, well 100 divided by 4 is 25, and 8 divided by 4 is 2. 25 add 2 is 27. And this has landed on quite a nice number, because if r cubed equals 27, then r is the cube root of 27. And I know that 3 times 3 is 9, times 3 again is 27. The cube root of 27 is 3. Question 15 is an algebraic proof. And if you're never sure what to do with these, then just do whatever algebra you can. So I'm going to look at this here and see I've got a double bracket. What I might as well do is expand that double bracket. So I'll use a grid method to do that. We've got 3n minus 5 multiplied by 2n plus 3. Let's just work that through. 2n times 3n is 6n squared. 2n times minus 5 is minus 10n. 3 times 3n is 9n. And 3 times minus 5 is minus 15. If we now rewrite what we started with, but include this as an expanded bracket, I've got 13n plus 3. And all of this is down here now. So I'm going to add 6n squared minus 10n plus 9n minus 15. And what we can do is start to simplify this. So we've got 13n minus 10n plus 9n. 13 minus 10 is 3, plus 9 is 12n. We've got a positive 6n squared, and that's all we've got. So I'm going to put that at the start. 6n squared, this would be positive 12n. And then we've got positive 3 minus 15. 3 take 15 is minus 12. What we're looking to do is prove that all of this algebra boils down to a multiple of 6. And look at these nice numbers. I've got 6, 12, and 12. So this here is 6 multiplied by something. And if we take out this factor of 6 and say, okay, 6 times something is 6n squared. Well, 6 times n squared is 6n squared. 6 times something is 12n. Well, 6 times 2n is 12n. And 6 times something is minus 12. 6 times minus 2 is minus 12. By taking out this factor of 6, we're saying it doesn't matter what happens in the brackets. I'm going to do that first because it's brackets. Then multiply by 6. Whenever you're multiplying by 6, you've got a multiple of 6. And that is the proof finished. Question 16, we've got quite a nice little circle theorem question. This is just explaining the diagram. And we're asked to work out angle x, which is there, and give a reason. Well, the fact that we've got a tangent, and then we've got a chord, and we're given the angle between those two. What we've then got is an angle coming away from that chord. This x must match 72. This is called alternate segment theorem. So angle X is 72, and the reason is alternate segment theorem. Part B says work out angle Y. Well, now we know that X is 72. What we're going to look at is this shape. And we've got a four-sided shape where every corner sits on the circle. This is called a cyclic quadrilateral. And these opposite angles will add to 180. So I'm going to do 180, take away 72, which is 108. So angle Y is 108, and the reason is opposite angles on a cyclic quadrilateral add to 180. Question 17, we've got a triple bracket that expands into this form, and we don't know what the numbers B, C, and D are, and that's what we're looking to find. So what I'm going to do is expand this triple bracket. I'm going to pick two of them, which is this one, and expand them. And I've picked those two because they look like what I'm used to expanding. This one here hasn't got a number, it's got an A, so I'm going to leave that alone for now. Let's expand those two brackets. We've got x plus 3 multiplied by 2x plus 1. 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is just x, and 1 times 3 is just 3. So this expands to 2x squared plus 7x plus 3. What I'm going to do now is multiply all of this by this third bracket. I'm going to do that down here. So we've got 2x squared plus 7x plus 3. And I'm multiplying by x plus a. Well, x times 2x squared is 2x cubed. X times 7x is 7x squared. And 3 times x is 3x. A times 2x squared is 2ax squared. A times 7x is 7ax. And a times 3 is 3a. This is my expanded triple bracket. We can start to pick away at this and compare it to what we're looking for. The only number term in this expanded bracket is there. There's no x's involved in that 3a. And the only number term up here is minus 12. So 3a must be minus 12. That means a must be minus 4. I can work backwards through this and maybe just look at my x terms. I've got 3x's and 7ax's, and they must match my x's up there. So let's write something down. We've got 7ax's added to 3x's, and that must match dx's. Well, we know that a is minus 4, so this becomes 7 times minus 4, which is minus 28, and 7ax would be minus 28x. I'm going to add on the 3x, and that's still the same as dx. Minus 28 add 3 is minus 25. So minus 25x is the same as dx. D must be minus 25. So I've got a, which I needed to get D. The only thing that's missing is C and B. So let's keep working backwards through this expansion. Let's look at 2ax squared and 7x squared. They're my x squared terms, and they must match cx squared. So let's write that down. 7x squared added to 2ax squared must match cx squared. I know what a is. I got a right back here. A is minus 4. So this becomes 2 times minus 4, which is minus 8. And then we've got x squared. I've still got 7x squared. And that still comes to c x squared. 7x squared take 8x squared is minus 1 x squared, which is still cx squared. C must be minus 1. Now, final thing I'm looking for is b. Well, b is just the number before my x cubed, which is right there. There is only a single x cubed term, so b is 2. Question 18, we've got a straight line passing through note 6, and we know it's perpendicular to this straight line, and we want the equation of that line. So it passes through this and it's perpendicular to this. So we've got several bits of information. When you've got the point note 6, you've got an x, y coordinate. So x equals 0 and y equals 6. We know this straight line, y equals 4x minus 5, is perpendicular to the line I'm looking for. Well, when you've got perpendicular lines, their gradients multiply to -1. So what we've got is 4 multiplied by our gradient that we're looking for is -1. So 4 times n is -1. M will be -1/4. We can just do -1 divided by 4. So the information we've got, x is 0, y equals 6, and our gradient m is -1/4. Let's put that into the equation, y equals mx plus c. You're going to get 6 equals -1/4 times 0, mx, -1/4 times 0 will be 0 plus c. 6 is 0 plus c. C must equal 6. C is always the missing thing when you're looking for the equation of a straight line. Now we've got our c, and we know what m is. They're the two things you need to write the equation of a straight line. You're going to write y equals -1/4 x plus 6. In part B, we're looking for the coordinates of the intersection of these two graphs. And if you're ever looking for the coordinates of intersection of two graphs, what you're going to do is solve these equations simultaneously. This is saying solve these simultaneous equations. So we've got y equals x squared minus 17 and y equals 4x minus 5. If these two things both equal y, then they must be the same as each other. So I'm going to write that down. X squared minus 17 must be the same as 4x minus 5. That has to be true because they both equal y. So they both equal the same thing. This is now a quadratic that we can start to solve. So I'm going to add 5 to both sides. And we get x squared, -17 add 5 is -12 equals 4x. Let's take 4x from both sides. We get x squared minus 4x minus 12 equals 0. When solving a quadratic, you'll always look to factorize first. So are there two numbers that add to -4 but multiply to -12? I think 2 and 6 will do that. Or more correctly, -6 and +2. They add to -4 but times to -12. So that's how I'm going to factorize my quadratic. X minus 6 and x plus 2. Still an equation, so still equals 0. Now let's solve this. X equals +6 and x equals -2, just the opposite of what's in the bracket. We've got our two x values, but there will also be two y values for simultaneous equations like this. So we need to find two y values, and we can use any of these. I'm going to pick the nicer one with no squaring in. So when x equals 6, y is 4x's take 5. 4x's will be 4 6's take 5. And 4 6's are 24, and 24 take 5 is 19. Let's go again, but this time x equals -2. Y will be the same. 4 lots of x becomes 4 lots of -2. Then take 5. And you get 4 times -2 is -8. Take away 5 is -13. We've got an x value and a y value. A second x value and a second y value. They're my solutions. Question 19, we've got information about how long it takes people to get to school. So 54 people take between 0 and 10 minutes. We're asked to draw a histogram of this information. And if we're going to draw a histogram, we need something called frequency density, which comes from the frequency divided by the class width, how wide this class interval is. So divided by class width. The first frequency is 54, so we're going to do 54 and divide by the first class width. Well, from 0 to 10 is a distance of 10. So our first frequency density is 54 divided by 10, 5.4. Second frequency density, well, we've got 50, and we're going to divide by how wide this class interval is. Well, from 10 to 20 is 10 again. So 50 divided by 10 is 5. Third frequency is 44. I'm going to divide by how wide this is. Be careful here, 20 to 40 is a width of 20. So I've got to do 44 divided by 20. Well, 44 divided by 2 is 22. So 44 divided by 20 will be 2.2. And final frequency is 20. And I'm going to divide by how wide this class interval is. Well, from 40 to 80 is 40. So I need to do 20 divided by 40, which is 2 divided by 4, which is 0.5. These here, 5.45, 2.2 and 0.5 are my frequency densities. Now, frequency density on a histogram will always be this scale. So I need numbers that are going to match the frequency densities I just worked out. Looks like I need to go at least to 5.4. So looking at this, I'm thinking 1, 2, 3, 4, 5, 6 fits perfectly. Let's plot these frequency densities. So I need to go up to 5.4, and I need to go from 0 to 10. So from 0 to 10 is there. Up to 5.4 would be here. That is the first bar in my histogram, from 0 to 10 and up to 5.4. The second frequency density is 5, and that covers a range 0 to 20. So from 0 to 20, but up to 5. There's your second bar. Third frequency density is 2.2, but that goes from 20 to 40. So be careful, I'm going from 20 to 40 and up to 2.2. 2.2 is there. Make sure you go from 20 to 40. And then final frequency density is 0.5, and that covers a range 40 to 80. So 0.5 is here, and I'm going to go all the way from 40 to 80. That is a completed histogram for this question. Part B of this question says a student is saying the longest time that any student took to travel to school was 80 minutes. Is she correct? Give a reason. Well, here's the table from the first part of the question, and we can see time taken 40 to 80. 20 students were in that zone, but we don't know what time they took. They could have all been 40, they could have all been 80, they might have been nowhere near 80. So we don't know what time these students took. There is no way we can say the longest time was 80 minutes. So we just need to write something that agrees with that line. All of the students in this zone could have actually taken less than 80 minutes because they might not have got an 80-minute late student in there. Part C says this student is claiming 25% of the students took more than 30 minutes to travel to school. So we need to find 30 minutes, and 30 minutes is here, look, in between 20 and 40. So what we can say is, okay, if the students taking between 20 and 40 minutes, there were 44 of them. Well, I might say that 30 to 40 minutes, kind of the middle of this group to the end of it, must be half of these students. And I know that there's 20 students that go from 40 to 80 minutes. So from 40 to is 20 students. These are all the students that take longer than 30 minutes. So more than 30 must be 22 add 20, 42 students. So 42 students take longer than 30 minutes. There are 168 students altogether. We're told that in part A, but you could add those up as well. So we're saying that 42 out of 168 take more than 30 minutes to get to school. Let's convert this to a percentage. 42 over 168 is 21 over 84. I can see here 21 times 4 is 84. So this actually looks like a quarter, and a quarter is 25%. That there is this, how she has worked out her claim. Part 2 says state one assumption that she's made in making a claim. Well, this maths here kind of saying from 30 to 40 there are 22 students, exactly half of the total, kind of goes against what I said in the first part, part B. We don't actually know what these 44 students took in terms of time. All 44 students might have taken 20 minutes. All 44 students might have taken 40 minutes. So they may be not evenly spread throughout this group. This bit of maths pretends that they're all perfectly spread across this group. So the assumption that we're making is that students are spread evenly across these groups. Question 20, we've got some laws of indices work. It's quite complicated, but we can work it through. We're going to substitute n equals 7 into this and figure out what k is. The first thing you need to know about this is whenever you've got a square root, you're raising to the power of a half. And without that knowledge, you won't be able to solve this equation. So what we've got is not root 2, we've got 2 to the power of a half. And I'm going to raise that to the power of 7 because n equals 7. We don't know what k is, but again, we know that the square root of 2 is 2 to the power of a half. We can simplify this side. 2 to the half raised to the power of 7. Well, that's just your normal laws of indices. We need to multiply these together, and 7 times a half is 3.5. So what we get is 2 raised to the power of 3.5 equals k times 2 to the power of a half. We need to look again at this left-hand side, and what we can do is break this apart. 2 to the 3.5 is the same as 2 to the 3 multiplied by 2 to the half. Again, just using your normal laws of indices. If I said 2 to the 3 times 2 to the 4, you'd say that's 2 to the 7. You'd add those together. Well, 2 to the 3 times 2 to the half is 2 to the 3.5. Just add them together. I've done the reverse of that and broke them apart. And that's still the same as k times 2 to the half. And what I can see now is k must match 2 cubed. I've got 2 to the half here. I've got 2 to the half here. 2 cubed must match k. And 2 cubed is 2 times 2 times 2 again, which is 8. Part 2 says find n when k equals 64. So I'm just going to repeat what I did. I'm going to use 2 to the half rather than the square root of 2. It's the same thing. So 2 to the half raised to the power of n is 64. K is now 64 times 2 to the half again. I know that 64 is 2 to the power of 5. 2 times 2 times 2 times 2 times 2 will give you 64. So we've got 2 to the power of 5 now times 2 to the half on this right hand side, and we're trying to match that up with this left hand side. Well, 2 to the 5 times 2 to the half is 2 to the 5.5. And we're trying to figure out what n is that makes that happen. So I'm just going to write this bit out again. That's 2 to the half to the power of n. We need these two things to multiply together to give me 5.5. So a half times something is 5.5. Half times something is 5.5. What do you half that gives you 5.5? The answer is 11. A half of 11 is 5.5. Part B, show that this can be written in the form a plus b root squared. Well, what we've got here is some surds. This is saying rationalise the denominator. To do that, we're going to start with what we've got. And we're going to multiply top and bottom by this, but with a reversed sign here. So I'm going to multiply by 3 plus root 2. And I need to multiply top by 3 plus root 2 as well. We end up with some brackets with surds, so let's treat them separately. We've got 14 multiplied by 3 plus root 2. And I'll do that first. 14 times 3 is 14, 28, 42. 14 times root 2 is 14 root 2. So that is the top of my fraction dealt with. For this bottom bit, I'm going to do 3 minus root 2 multiplied by 3 plus root 2. And if we treat these as double brackets, that's what they are. 3 times 3 is 9. 3 times root 2 is 3 root 2s. Negative root 2 times 3 is negative 3 root 2s. And negative root 2 times positive root 2. Well, root 2 times root 2 is 2. We've got a negative times a positive, so that'll be minus 2. We can tidy all this up. When I chose the reverse sign here, so not subtract but plus, that gets rid of this. It has this effect. You'll have plus 3 root 2s, minus 3 root 2s, they're gone away. And all we're left with is 9 take 2, and 9 take 2 is 7. Your final fraction simplifies to, this was the top, 42 plus 14 root 2 all over 7 which is that. And it looks like there's a little bit of simplifying to do as well, because I don't actually want a fraction in my final answer. Well, 14 divided by 7 is 2. 42 divided by 7 is 6. So what we're left with is 6 plus 2 root 2's.